Okay, I just shared the link. So let's go on. We're still in Unit 1. We are in week 3. Let's do, seems like I have a folder called review. I'm gonna create a file here called review topics. And you're gonna help me fill out this file. So let me open that with Adam. Oh no. And you're gonna tell me what we have seen so far. So who remembers what was the first thing that we learned? Variables? Even before that? Right. Sandra, a little bit louder. Okay, mathematical equations. Is that how you spell it? Yeah. Cool. But even before that, Git repo, yeah, that came before. And before that, Joanne? Command line, that's correct. Now we can abbreviate it to CLI, command line interface. Okay, let's list all the topics. Okay, math equations were, I think, part of variables, variable type and operators. What else? After variable types and operators, what did we learn? Shaina? Conditionals, I think. Yeah, somebody else? Suzette? Loops? Loops were before strings or after strings? After strings? Before strings? So strings comes after loops? Strings, okay. And the last thing? Arrays. Okay. Let's verify this with a list that I have made earlier. And CLI, Git and GitHub, value types and operators. Oh, value types, this was. Value types and operators. And then we saw variables. Conditions, loops, strings, and arrays. Right, we got them mostly right. Okay, so let's go review. Let's go reviewing kind of in this order. So, what's the command line? Let's see, Douglas.
It's the terminal itself. It's non-graphical.
Right, the non-graphical interface. What is the graphical interface? Maybe somebody else. Michael? HTML page? Not quite in this context. Pupil? Right, everything you see in the screen here, for instance, these buttons are part of the graphical user interface. This menu is part of the graphical user interface. And why is it called user interface? Like, where does that come from? Owen? Right, exactly. That's how humans interact with the computer. An interface is just like that bridge between the user and the machine. So one kind of bridge is the graphical user interface, or also known as GUI, where we have buttons, we see stuff, we turn knobs, we slide sliders. Those are all parts of or components of the graphical user interface. The command line interface is where we literally have a command that we type, like let's see, Git, and well, it's literally a line, and the interface part means again that bridge between the machine and the computer. Cool. So what is some of the stuff that we could do from the command line? Pupil? Change directories. Okay, yeah, that's something we could do. Anybody else? Sure. We could erase everything in our laptop, right? If we do rm rf/. Don't ever run this. This will run like this will literally run like remove everything. Yeah, everything. I mean. Yeah, as I said, you had a question. You can make folders, right? So you can navigate, and to summarize all the stuff that you guys have been saying is you can control your computer from the terminal, right? You can create folders. You could open apps like the way I open Atom. You can run programs, right, like Git. And okay, so now that we saw that, what are some of the commands that we learned in the command line? I think, Hugo, you said we can move into directories. What's the command for that? Right, so if I'm in my home, I'm going to go to my home, for instance. This CD stands for changing directory again, and the tilde, or squiggly line, some call them, stands for my home. So in here, I was able to move from a folder called review to my home. Cool. What's other commands that we have been using commonly? PWD. What does this one do? Lets you know where you are. Exactly. And then this stands for print working directory. And the working directory is where you currently are, right? So now it's telling me that I'm somehow in a folder called users, inside a folder called Alejandro. All right. So PWD. Let's see one more command. Peter. Touch. What does touch do? Right. Now if I do ls, which is another one of those commands, I can see my file was created. Camille. Make dir. What does this one do? A directory. I do ls, and I should see it at some point. A directory was created here. Cool. So those are some of them. Anybody else wants to comment on one of the commands that we have learned? Douglas?
Space period comes up one directory to one parent.
Right, so that one, let's do print working directory. So it seems like we're in a folder inside users who has a folder called Alejandro. If I do this, we could say kind of special version of CD, or not, it's not really a special version, is the name that we're providing here or where we want to go, the two dots, stand for the parent directory. So the parent directory of the folder Alejandro is users, right? So if I do cd ... I should be now in a folder called users. So if I do now print working directory, I can effectively see that I moved up to the parent of the current folder. Okay. So we saw command line. What else? Do we have Git and GitHub? So what's Git? Let's see, Giselle. Local repo. Okay. Right, it's a local repo. It allows us to create a local repo, that's correct. And what that means is it creates a special kind of folder, or it enables a folder to keep track of the changes that happen in that folder. right? Anybody else want to add to Git? Okay, so what if, so how do I run Git? We know what it does. It enables a folder to be able to keep track of the changes. So how do I utilize it? Chuck, how do I use Git if I want to use Git? Could you be a little bit louder? I'm really having a hard time to hear you. Okay. Let's see. I'm sorry, I'm really having a hard time. Who can help Chuck? Please, sorry, you. We use it for version control. Okay. And then how do I use it? How do I actually interact with it? It's a tool, right? So how can I use that tool to keep track of changes? What's the first command that we run as Git? Joy? Right. Okay. So let's create a folder here. Actually, I'm gonna call this folder I want to be a repo. Oh, I cannot go into the folder without having it created. Now I want to go in there. And Joy said, if I want this folder to be a true repo, a Git repo, I could do git init. Right? And then now, I think I could have this completely. Nothing seems to have happened. My terminal shows me here something master. Your terminal might not show you anything. But if you want to verify that this folder has been truly enabled to be a Git repo, something you could do is git status. That should show you that you're a branch master, no commits yet. Another way to verify is if I do ls, I don't seem to see anything. But if I do ls-a, now -a is asking to list everything in this folder, even hidden files. And it turns out that Git, everything that starts with a dot, any file name or folder name that starts with a dot is going to be hidden by default. That's just the way that Unix systems were designed. So now it shows me that I have something called .git that in a folder that is not a Git repo should not have. If, for instance, if I go to my home, I have a lot of stuff in my home. So let me go to desktop. I'm gonna do ls-a. Here, I don't have a .git folder, right? Because this is not a folder that has been enabled to keep track of changes. Okay. So let's go back. Thank you. I recommend it to everyone. Like, it's how to influence and influence people. The book, the title might sound obnoxious, but if you read it, you'll realize otherwise. Okay, so now we have a folder called I want to be a repo. It's truly a repo because if I do git status, then it shows me that I'm there. And I already verified that it has a .git folder inside. So that's just to double check. I always, as programmers, that's something that we have to do often. Always double check our assumptions. Okay, what else can I do with Git? So now this folder has been enabled, but what's next? Douglas?
Git add.
Git add. What is git add going to do? Yep.
And it's going to mark a change, or it's going to put the most current version of your local
That's close, but not quite there yet. Hubel? Right, so Hubel said he sets a file or all the files to be staged. And what does, that's good that you're using the right word. Now, what does that word mean? What do you think? Okay, that's fair. Camille? It preps it, right. I like that, yeah. It is kind of telling Git to keep track of this file. Like, just acknowledge the changes that it has and keep track of it. And then after that, we're going to commit the file, right? But in here, do I have any files to add to tell Git keep track of this, please? Right. So if I just do that, and I hit enter, it says nothing specified, nothing added. Maybe you wanted to say git add period. And then git add period means add everything in the current folder. But if I do that, nothing seems to happen. Let's do a git status. We're still not commits yet. Nothing has happened, right? Because git add requires either a file name or files to exist and be modified in the current folder for it to take effect. So let's do that now. So let's create a file in the file.txt. Now, if I do git status, Git notice that there is a new file. It says untracked. So Git notice that there's a new file. Now I want to ask Git to keep track of that file. I do that with git add, then the name of the file. But actually, let's do git status. Let's see what that did. Now when we did git add, you notice that, well, actually this might not be in your computers in the fact that it shows you different colors. If you're interested in getting colors, send me a Slack message and I could help you set up that. But in here it's telling me that it was an untracked file, .txt. Now here it says, oh, okay, now you have asked me to keep track of that file. Git is just keeping track of it, but it hasn't finalized any changes. So let's go on to Atom and add something to the file. Save the file, go back to the terminal. Now we do git status, and now we have something very confusing. We have a new file in two places. This is Git saying, I took note that there is a new file, right? And you asked me to keep track of it, right? And then after that, you made some changes, and now I'm telling you here that those changes, that I took note of those changes, that Git acknowledged that file from this state where it was empty changed to the state where it had hello world in it. So now to ask Git to keep track of the new changes, I do git add file.txt. And now to kind of finalize or like truly save my changes to Git. Well, actually, let's do git status before we do that. Now we have changes to be committed, a new file with the hello world inside. And now if I truly want to finalize that, I'm going to do git commit. Git commit requires you to pass a message. In here, you explain what happened in the file, explain what you did. Preferably in the present tense. So here I'm going to say add hello world. I git commit that, and now if I do git status again, I see that I'm a branch master, nothing to commit, right? I have no changes in my current folder. So in other words, or in Git terms, my working tree is clean. But now I could look at my history at what happened if I do git log. Git log tells me somebody, or actually Alejo, on July 10th at 7 p.m. added hello world to a file. So we're going to see how this becomes really paramount once we're working in a team. And once we mess up our code and have to go back to an earlier version for whatever reason, and Git is going to enable us to do that. Okay, so that's Git. It's a tool to keep track of files. Yeah, Renee? So you said something when you upload your file to Git. We upload our repos or update our repos in GitHub, but Git and GitHub are different. So far, these changes exist only on my local computer, right? If I lose my computer right now, this is gone, right? So that's where GitHub comes in, where GitHub is a service that allows us to save our local Git repos to a computer in GitHub, now Microsoft. So, and that's like, I remember that the name that it didn't make sense to me at the beginning, GitHub, whereas is the hub for Git, right? For some reason that didn't make sense to me at the beginning, but it's kind of good to know. Okay, so now if we want to upload our files to GitHub, we go on GitHub. We create a repo here. You don't have to name it the same as your local folder, but I prefer to do that to be consistent. I set it to public and I hit create repo. Now here, GitHub tells me instructions as to what steps I need to follow. Yeah, sure. Say that again? Yeah, so you can have the difference between public and private is that other people in the internet are not going to be able to see it, but you can still, if your repo is private, you can still add contributors to their classmates or people who you're working with. They will still be able to see it. So here Git is telling me to do these steps to add a remote. That went well. And then to git push -u origin master. This line here, this one is saying, okay, when you are pushing, push to this URL, right? When you're uploading, push to this URL. And then the next thing is to actually push, we do git push. Now that seems to be uploading my code. I go now on the browser, I refresh this page, and I see my file there. And now, if I lose my computer, I could still be able to work because now I can just clone my repo in another computer, right? And to Renee's question, once you create a pull request, you can still keep working in your code, and because when you create the pull request, it's coming from, I think it's kind of hard to explain it at this point, but it's, when you create the pull request, you're saying, okay, I want to combine my code with this other original code the original code will be the code you forked from, right? And then you're also saying something that we haven't touched on, which is branches. You're also saying, I want to merge my master branch to this master branch of this other repo. And when you add and you keep working after, when you add and commit new changes, Git automatically sees that if those changes are going to the master branch, which so far they have been going to the master branch, is going to acknowledge that and let you, it will take them as part of your pull request. I don't know if that makes a lot of sense right now, but if you keep pushing, those new changes will be taken into account. That's the only thing that you truly need to remember. Okay, we still have some topics to review. Let's see. So that was Git and GitHub. Let's go on value types and operators. This is where we actually get to JavaScript stuff. JS. Okay. So how many, let's see, how many types do we have in JavaScript? How many value types do we have in JavaScript? And what does that mean, value types? Camille? Booleans, right? Boolean strings, that's correct. Let's put them here. Booleans, Booleans. Strings, okay. Somebody else contribute one more or two more. Numbers. Undefined. Michael? Objects. We haven't gotten to those, but yes, those are different data types. An array is incredibly an object, yeah. Mm-hmm. So we have seen them. We just didn't take note. Anything else? I think there are 6. No, I think it's 1. Not a number. Who can confirm on that one? I'm not sure. Let's see. If we do type of not a number is a number, which is kind of weird. Node. If I do type of man, says it's a number. Yeah, this is one of those weird corners of JavaScript. Not a number is a number. Okay. So let's look at some examples. So who can give me an example of a Boolean? What are Booleans? Joy? That's correct. Yeah, a Boolean. Karen, an example of a Boolean. Anything that returns true or false here, right? So a Boolean will be either true or false. And what you're saying, anything that returns true or false, that will be a Boolean expression, which will be kind of the next thing. Boolean expression. Right, so let's do, this is true or false. Boolean expression. What would be an example of a Boolean expression? A comparison? Give me an example. Something equals something else, like maybe 1 triple equal 1 or 2. Yeah. Right, this will be a Boolean expression. When do we use Boolean expressions? Douglas? Who can complement that? Yeah, Camille? Right, when you have a conditional where you kind of want to ask a question to test for something, right? In this case, we're testing for equality. And they are mostly used in conditionals, right? When we want an if statement, or a condition in a while or a for loop, right? Cool. What about strings? What are strings? Renee? Right, they are quoted. And what was the other thing? Okay, if it has quotes, it gets logged to your terminal as a string, right? Okay, so it could be something like hello. And a string could be anything that's in quotes. It can have it has characters inside, and those characters can be letters. It can be symbols. It can be numbers. Can be symbols, I guess, like the plus sign, etc. What are those useful for? What are strings useful for? Like, why would a programming language decide to include strings? Hugo? Right, if you want to add text to anything or you want to print a sentence. And if you think about, like, computers are made for us, for simplifying our life. And we understand words, we understand sentences, right? So it makes sense that a string has a mechanism to allow us to communicate that. Anything else about strings? Cool. What about numbers? This should be pretty straightforward, right? A little bit louder. I'm sorry, I couldn't hear it. One more time. Right. When we use in math, for instance, right, the result is usually numbers, right? So we can have 1 plus 2, right? That will be equal to 3. What about some special numbers? JavaScript has some special numbers. We just saw one here, right? We have to be aware of those. JavaScript has special numbers. So nan is 1. Who can give me another special number in JavaScript? Infinity. And the opposite of infinity? Minus infinity, right? And also the fact that numbers in JavaScript can be floating point, which means decimals. So I can have something like 0.1 plus 0.1. Right, so can be floating numbers. Right, anything else in numbers, Michael? A little bit. Irrational numbers. I think you're testing me on my math knowledge, and I'm not that good. But if you could explain what those are.
The hash numbers irrational or continuous, continuous is something like a 10 divided by 3, like 3.33.
Right. I think I do. If I do 10 divided by 3, is that what you mean? I guess we'll need to discuss the definition of continuous that you're. Oh, that it rounds up at some point, right? Yeah, well, we can talk about that later. Right. So what about undefined? So if we do type of undefined, we get undefined. When do we have undefined values? Hugo? Right, so Hubel's example is if we have an array of two things and we try to access the element at an index that doesn't exist. So here I have an array A. If I try to do array A at index 3, I get undefined, right? That doesn't exist. Another example is if I do let B and I just leave it like that, when I do console log B, I have undefined, right? That variable has not been defined. No, it's holding no value. Any questions so far? Cool. Object. We're not gonna get into that yet, but if we do, some of you might have tried this, which is type of an array. It gives us an object. And we're gonna see how in JavaScript most stuff is an object, and we're gonna truly see what that means. For now, we don't have to worry too much about that. And then null is similar to undefined, but it's implying, it's explicitly saying there is no value. So we could do something like, if we truly want to say, I want to start this variable A. Actually, that was already taken. And I want it to hold no specific value. I could say equal to null, right? Okay. Any questions before we move on to variables? Do this.
Just a quick, so null is defined, no value, whereas if null also.
Say that a little bit louder and
No,
again.
Is a null undefined, whereas a null defines no value.
Null is a defined known value. Mm-hmm. Okay, so how do we feel about creating variables in JavaScript? What are the three ways? Let, var, and const, right? And then we saw that by defining a variable, we have the left side, let, the keyword let, and the name of the variable. We have the assignment operator, which is 1 equal. And to the right, what we want to assign to that, right? Now it's pretty straightforward. If we skip, we already saw that if we skip the right side and the assignment operator, we just end up with a variable whose value is undefined. Cool. Now, conditionals. What are conditionals in JavaScript? Let's see. Amin? What are conditionals? Okay. Who can complement that definition? Lewis?
A statement that returns either true or false.
We're getting close. Anybody else? Sorry, you?
It's a statement that works only if a certain condition is met.
Okay, that's a little bit more complete, right? It's a statement that can be in the format of an if statement that runs the code if the condition is true. So, for instance, if I do if, the simplest conditional is an if statement whose value is checking for truthy. And then if true, I want to console log it's true. Right? Now that conditional statement, if statement, check for the condition was true, then we ran the body of the if statement, right? And what's in the body of the if statement is just a console log. Cool. Any other examples of conditionals? What's another way in which we could write conditionals? Or other kinds of conditionals, rather. We saw a few. Jonathan? A while loop, yeah. A while loop will have a condition to check for how long should the loop run. Anything else, Khadija? An if and an else, right? This if could have an else. I'm writing it in one line, but best practice is to do it in multiple lines. I think I could do that. Yeah. It's kind of hard if I'm in the terminal. But if else, okay. Anything else? We saw two more. We saw two other conditional statements, or forms or kinds. Ternary. So we could say the same question if we do true, then console.log. Let's go with something more that maybe makes a little bit more sense. 2 less than 4, then console log 2 is larger. No, 2 is less than. Else two is smaller. Right? That ternary will execute. We have see 2 is less than. Wait, actually what? Less than. Oh, here is larger. Right. So if we flip now the condition, we do 2 is 2 less than 1. Now 2 is larger. Right. So this is another one. The last one, yeah, Cameron, the switch statement, right? The switch statement is where we can have multiple cases for the evaluation of an expression. And let's see if we could have a simple example. I'm not sure if we can run it here. Let's see. Switch, let a equal, let num equal 1. Now switch num, switch. What am I missing here? ST. Right. And then I could do, okay, in case num is 1, in case num is 2, oh, wait. In case num is 2, then console log num is 2. Now we break. Then in case num is 1, we say console log num is 1. Break. And close that. Right, now we say num is 1. That's weird. Who could see where my error is? Case 2. What is my num? I defined it earlier. Num is 1, right? So, oh, and unfortunately, there is no true way that I could run it again for the other case. So let's just leave it there. Cool. So we saw if statements, ternary, switch. After that, we went into loops. Why are loops useful for us? Why do we think? Yeah, Camille. Uh-huh. Right. I feel like I wouldn't say it will do it faster. Well, it will be faster compared to if we do it manually, right? If we have to. Right, especially when let's say we have an array or a string and that's like really long, to find whether it has a specific word that we're looking for. That'll be for us as humans, it will take us a long time to find that, right? But with a loop, we can find that. Right, and I think the goal of loops is to also, yeah, Karen? Right, exactly. We use loops for stuff that's repetitive, because we humans don't like to do repetitive stuff, right? We better have the computer do it for us. Yeah. Any questions so far? So what are the loops that we saw? For loop, while. Some of you discovered some other loops, I think. For off and for in, right? Do while. For each, those are loops, but more on the array side. Mm-hmm. But those, like, the two important ones are for loops and while loops. Okay, we went on over strings earlier. Now arrays. Yeah, Owen. Good question. When should we decide to use a for loop over a while loop? Who has a comment on that, or who? Yeah. When, like, why would I ever want to do a while loop, for instance? Yeah, Cameron.
Sometimes in your you want similar examples kind of themselves.
That's a good point. Right. What Cameron is saying is when we have a for loop that I equals 0, while I is less than 10, I plus plus, console.log I. When we have this for loop, this variable I doesn't exist outside of the while loop, of the for loop. So if I do console.log I, it says I is not defined, and it might be hard to see where how that could help us, or not, in the sense of if we have this in a while loop, instead the variable will exist outside of the loop, right? Which will make the variable available to the global scope. If for some reason, let's say after we did this work, maybe we wanted to keep the last value of I, right? In that case, then I could use a while loops to keep the last value of I, right? Any other questions on loops? Cool. Now we saw strings. And what are some? Let's see. How do we remember the two similarities, or I don't remember if it's two or more, that strings and arrays have? Hupel? Right, both are indexable or indexed. So if I do hello, and if I want to access the first index of hello, I get only H, right? The same goes for an array. Say this. Now I have, this was a string, and I say, give me the element at index 0. That's the first character. This is an array with 2 letters in. Each one of them is a string, has the letter H, the letter E. Give me the element at index 0, that is the H. What else? Length, they both have a length property. If I do array.length, I get how long it is. Let's do it for this one. String.length. The length is 5. We have 5 characters. Right. Any other similarities? Both of them can be sliced. So do we remember that a string has a method slice that will make a copy or will take a slice from the string? So if I do maybe start a copy from index 1, now I get that. If I do it in an array, this array with 2 letters, slice started at index 1, I get. We have an array with 2 elements. This is at index 0, this is at index 1. Now I want only a copy starting from index 1. This is index 1, right? So strings arrays, when would I want to use an array instead of a string? Or why do you separate? Yeah, Joanne? Right, if you have a list, it's better to keep track of that list in an array. Is that what you were suggesting? Right. I think the chart. Do you have your? Yeah, or right. An array is mutable. A string is immutable. So coming back to this example, I have the string hello. If I do string hello at index 0, I want to change that to capital H. Oh, I don't need the period. That seems to have worked. Well, I'll need to put hello in a variable. Let's call it H. Now I do H at index 0, change that to capital H. This gives me that, but we can ignore that for now. We look as to what H is. H still lowercase hello. Right, let's try that with an array now. Let's do, this is going to be our array. And it has, let's put now numbers in it. Oh, H is already defined. Now if I do, I want the first element of H to, instead of being 1, I want it to be 100. Let's see. Now let's console log, let's do H. Now, because it was an array, and arrays are mutable, I was able to say array at index 0, the first element, change it to be 100, and indeed it changed to be 100. Cool. Any questions, comments? What other stuff can we do with arrays? Some of the methods that we saw yesterday. Camille? Right, we could add stuff to the back if we do push. Now if we do H again, now we see that it has a 4. We could remove stuff. Anything else? Pop, right? Pop will remove from the end. Shift and unshift, right? That will add and remove from the front. splice. What does splice do? Splice is an interesting one because it does two things, or it can do two things. It could add and it can remove, right? Let's look at an example of that one. h.splice. I want to remove the 100, which is at index 0. I want to remove only one of them, and instead of 100, I want to add. Actually, I want to remove the 2, and I want to change the 2 to 200. Now, if I do splice, gives me back. Oh, I feel like splice gives me back the element that was removed, and that's what I see here. When I do h, now I made a mistake in my calculation where I said index 2. That's 3, 0, 1, 2. And then I asked it to remove one thing and instead put 200. Right, and the 4 is no longer there because we have popped it here. Right? Yeah, Camille? With now h is this. To this one?
Where you have h slicing, you right the
Uh-huh.
You always say you put the index and then the amount of things you want to. If you put 2 index 2 and 2 instead of 1, it will remove the.
That's correct. But yes, but in that case we no longer have the 4 because we popped it here. But it will work as you said, if we had the 4. Okay, so that concludes our quick review over the topics that we learned over the past week. Now for I went some time over. Now we have a guest in the house to introduce us to whiteboarding and what that is, how we can deal with it. So please give it a warm welcome to Ben Sussman. I'm gonna let Ben introduce himself. So Ben, thank you for being here.
Thank you.
Do you wanna use this?
Sure. Is it helpful? Do you want me to use that thing? Yes. Okay. Sure. Okay. Boom. Hello. 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 Hello.
I think that's
Do you want to take your computer, or do you want me to use your one? I brought my own if you want. Cool. How's it going, everybody? I am Ben. I'm pretty loud, so maybe just go ahead and take this thing. Yeah, I don't know. Maybe you've met me already because I taught the JavaScript class, but maybe that was somebody else. I don't know. I can't remember anymore. Thank you.